So our learning target for today is I can reason using benchmark numbers to compare fractions on the number line. Before I go ahead and do that, I'm going to notice my two fractions are 7/8 and 6/4. I'm noticing that both of my denominators are even, so I'm going to have a very clear half benchmark, right? My benchmark numbers are 0, 1/2, and 1 whole. But I'm also noticing with this fraction, my numerator is larger than my denominator. This means that we have more than 1 whole with this fraction. So I can use a number bond. I'm going to use a side number bond right now just for space. I have 4/4 is equal to 1 whole. And I've used 4 of my 6 in my numerator, so I have 2/4 remaining. So I need to plot on my number line so that I have more than 1 whole. So I need to show that. So I'm going to do that with my benchmark numbers. I have 0, I have 1, and I have 2. And I'm going to put my 1/2 mark right here. So I've placed all my benchmark numbers, and this is actually 1 and 1/2. So I'm going to start with 7/8. I know that 1 whole in 8ths is 8/8. So 7/8, this is 0. 7/8 must be right around here. I also know that 6/4, well, 4/4 is 1 whole. And I have a little bit larger than 1 whole. I have 4/4 and 2/4. 2/4 I can see is equivalent to 1/2. It's the same as 1/2. If I was going to divide 2/4 by 2, I would get 1/2. If I didn't know that, I could say to myself, all right, I'm going to partition this space between 1 and 2 evenly in 4. So I have 1, 2, 3, and this is 8/4. Because 4 plus 4 is 8. So 8/4, 4 goes into 8 twice. So I really have 1 and 1/2, which means 6/4 would be plotted right here. I have 7/8 right here. I'm looking at my number line. 6/4 is further along, which means that 6/4, I'm going to erase this on the bottom, 6/4 is larger than 7/8. So I've used the number line to show that 6/4 is larger than 7/8. My job is easier because I know the numerator is larger than the denominator. It must be bigger than 1 whole. In this case, the numerator is smaller than the denominator. But we're also going to be asked to compare some fractions that are both what we call improper fractions. That's when the numerator is bigger than the denominator. So we have 5/3, we have 9/5. How can we figure out which is larger using the number the number line? Again, we're going to place our benchmark numbers, and I can already see that in both of these cases, my numerator is bigger. That means I need to show more than 1 whole. I'm going to put the 1/2 marker, so I have my 0, 1, and 2 whole numbers, and I have my 1 and 1/2 here, which is my other benchmarks. So again, now we've added a benchmark number as we have a whole other number. We have our 0, 1, and 2. We've put our halfway markers on our number line. Looking at this fraction, I know that 3/3 is equal to 1 whole. That leaves me with 2/3 left. And right here, I can put my 3/3. I know that if I double 3, I would have 6. 3 goes into 6 2 times, so 6/3 is my 2 wholes. So where would 5/3 go? Well, if this is 3/3, I'm going to put 4/3 here, 5/3 would go right about here. I'm going to do the same exact thing for this other fraction, 9/5. I know that 5/5 is equal to 1 whole. I know that 5 plus 4 equals 9, so I have 4/5 left over. So I have 5/5 plus 4/5. Again, I'm going to go to my number line. I see I have my whole. I'm going to put my 5/5 there. I know 5 plus 5 is 10. So 10/5 will be under my 2 on my number line, and now 9/5 is going to be, I have to partition this part of my number line. So I have 6/5, 7/5, 8/5, and 9/5. So 6/5, 7/5, 8/5, and 9/5, which is a little bit larger than 5/3. So 9/5 is the larger number when comparing. We're going to use these two examples, and then we're going to try one on our own, and then we can go to the worksheet.